we go, guys. We're going to be looking at solving absolute value inequalities and compound inequalities today. It's something that you've done before. You guys remember and problems and or problems, intersections and unions. Those are the things that we're going to be looking at when we're dealing with compound inequalities and absolute value inequalities. Absolute value inequalities actually become compound inequalities because of the definition of absolute value. Right? So let's have a look first at a couple definitions, some vocab that we need to understand. The intersection of two things in mathematics, it's the shared portion of two sets. What do they have in common? You know, if we talk about the intersection of Getwell Road and Goodman Road, that's a very specific place, right? The real estate that's there is, you guys know you pass through it every day to get here. Most of you do. It's an intersection. It's the shared portion of two roads. Right? So that little space is on both roads. Right? It's on Getwell Road and Goodman Road. All right? So the symbol that's used to indicate intersection is that upside down union. But if you flip that thing over, the U indicates union. The word in mathematics that indicates intersection, I just said it, is the word and. Right? If we're on Getwell Road and Goodman Road, then that's the intersection of the two roads. It's the only place in the whole world that's on those two roads. It's really that one little, probably 80 foot by 80 foot space right out there. Right, so it's on both roads. It's Goodman Road and Getwell Road. It's the intersection of the two things. And I say that because I want you to remember that intersection is indicated by the word and. Okay? All right? Now, what's the other relevant word that we're going to deal with here when it relates to compound inequalities? We can talk about the intersection of two sets, or we can talk about the anybody? Somebody. Union of two sets. Thank you. Yes, the union. Thanks, Mary. The union is the joining of the two sets. You just put the two sets together. Okay? Now, you got to be careful because the union of two sets and the intersection of two sets, the words that we use here have opposite meanings from our conversational language. Okay? In conversational language, and is inclusive, right? And is inclusive, yes? Or is exclusive. I need a Coke or a Dr. Pepper. It excludes one, right? That means you one or the other. In mathematics, a Coke or a Dr. Pepper means both. Join the two sets, okay? Conversationally, it means Coke and Dr. Pepper. So you got to be careful with these two words. The word intersection is indicated by and in mathematics, intersection is very restrictive. We just talked about Getwell Road and Goodman Road. It's that little 80 foot by 80 foot square out there in the intersection, right? If we talk about Getwell Road or Goodman Road, that's a huge piece of real estate, isn't it? Goodman Road goes all the way across the county, all the way over into Marshall County. Getwell Road goes all the way up north into Memphis and way down south into DeSoto County. And that's a bunch of it. So, or in mathematics is inclusive and is exclusive. So it's a little bit different. The symbol for intersection is this capital U. We won't use that a lot. The word that indicates union in mathematics is or. So if you see the word or as it relates to two different sets, then that means you just jam the two sets together. Everything in both sets is in the union of the two sets. It's in the or of the two sets. Or is inclusive and is very exclusive, right? And is more restrictive. Okay? All right, so we're going to be kind of looking at this example. I don't really love these examples, but this kind of shows what an and compound inequality would look like. And I'm not going to ask you to graph to do all three number lines like this, what I want you to do in this instance, if we were talking about x is greater than or equal to -1 and x is less than 2. If that's the little simple and inequality that we're looking at, here's how I want you to graph it. I want you to put the two relevant numbers on the number line. Up above the number line, I want you to sketch the graphs of these two inequalities, right? So x is greater than or equal to -1, that's a closed circle and shade this way. Right? Some of your teachers may at some point have had you always graph the inequalities above the number line. Any of your teachers ever have you do that? Some of the Algebra 1 teachers around here did at some point. I see one person shaking their head. The other one, nodding rather, x is less than 2 looks like that. The intersection is this little region where the two lines cross over each other. That intersection is what we're interested in because this word "and" tells us that we only want the set of numbers that satisfies both inequalities. And that set of numbers is everything between -1 and +2. Now, can somebody tell me why -1 is closed in and +2 is open here? Right, and -1 is shaded on both graphs, right? -1 is shaded on this graph, it's shaded on this graph. 2 is not shaded on one of the graphs, and so it cannot get into the intersection of the two graphs. All right? Do y'all remember this a little bit, the ands and the ors? Now, an or graph, and again, we're going to look at a little bit differently here. Well, let's look at this example first. You're going to need to write this one down because you may or may not have done one that's this difficult before. 10 is less than or equal to 3y minus 2, which is less than 19 plus y. Any ideas what we would do here? Any ideas? Subtract the y, that's a good idea. That's a good thought. But if we subtract the y, like if we went through here and subtract y, we would have to do it in all three places, right, to keep the thing in balance. So we'd have to subtract y there, subtract y there, and subtract y there. Then we would have 10 minus y is less than or equal to 3y minus, 2y minus 2, which is less than 19. Now, I haven't really helped myself, but your instinct is really good.
Separate them.
I have to separate these two, right? There's two inequalities here, and I cannot solve these in conjunction form. I have to separate it into two different inequalities. Now, in this inequality, y'all be careful of this word that I'm about to use. In this inequality, this middle part is being compared to this number and this expression. So I've got two inequalities here that I need to create. 10 is less than or equal to 3y minus 2, and 3y minus 2 is less than 19 plus y. Right? Now we've got two inequalities that we can solve pretty easily. We can add 2 on the left side here. We can add 2 and divide by 3, and we end up with y is greater than or equal to 4. Right? Over here we can subtract y, add 2, and I know I'm skipping a bunch of steps, but you know how to solve these inequalities, right? Subtract y, add 2, we get 2y is less than 21, which means y is less than 21 over 2. 10.5, is that what that is? 10.5. All right? This is an and problem, so how did we just say that we were going to graph an and problem? Above the number line, and then only the intersection is going to go on the line. So I've got 4 here, 10.5 somewhere up here, 21 over 2. Got to be careful how we graph this one, don't we? 4 is less than or equal to y is the same as what? Y is, which way do I shade? Right? You only shade the direction of the arrow if the variable is on the left. Okay, so 4 is less than or equal to y. What does that mean? 4 is the smallest thing y can be. Y is everything bigger than 4. Right, so Logan, think about what you might plug in for y here to make that true. Could you plug in 3? Is 4 less than or equal to 3? No, so we have to go the other direction, right? 5 is less than or equal, 4 is less than or equal to 5. 4 is less than or equal to 6. 4 is less than or equal to 8. So if you ever get confused, you can pick values and plug it in. Okay. The other side, we have y is less than 21 over 2. That's this, shade to the left. And then we can clearly see the intersection of these two sets, right? The intersection of these two sets is everything between 4 and 21 over 2. That's the graph of this set, the graph of the relation. We did an interval notation review just a couple of days ago, did we not? Did we do that in here? Yes, we did. Okay. Any questions on that before I move to something else? Because I want you to learn to express this in interval notation. So if we had this same solution set that we just looked at, it was everything between, was it 4 and 21 over 2, including 4, but not including 21 over 2. There's my solution set. The interval notation for that would be from 4 to 21 over 2, and I would need a bracket on this side, right, and a parentheses on that side. Remember, brackets show the closed circle, and parentheses show an open circle. Right? Good? What were the other rules of interval notation? Smallest value has to be on the left. Largest value has to be on the right. Closed circles get brackets. Open circles get parentheses. Infinities always get parentheses because you can't equal infinity. There's no closed bracket. There's no hard ending point there. Okay? So let's move on. This is an OR compound inequality. What's the difference between and or? Well, this one's already separated for us, right? Sometimes the and problems will be also. You can't write an or problem as a conjunction, a compound inequality with, it has to have the word or. So that is one difference here. But what's the general difference between and or? And is intersection and or is the union of the two sets. So we're going to solve these two inequalities and we're going to just slap them right together on the same graph. We're going to make a union. If we subtract 3 from both sides there, we get x is less than -1. Or, how do you finish solving negative x is less than or equal to -4? How do we finish solving that one? Divide both sides by -1 or multiply both sides by -1. And this is the big difference between solving inequalities and solving equations. Anytime you multiply or divide both sides by negative, what do we have to do? We have to flip the symbol, and that's going to be greater than or equal to +4. Now here's how I want you to do OR problems. There's not 3 graphs, there's just one graph, and because it's an because it's a union, we're just going to join the 2 graphs together on the same number line. And whatever happens, happens. If they cross over each other, then so be it. We're not looking for an intersection. We're looking for the union of these two things, and the union of these two things is going to look like this. Okay? Now let's talk about what am I trying to say? Interval notation. There it is. Too many diet sodas. It's messing up my short-term memory. What's the interval notation for this solution going to be? It's two different intervals, right? We've got this interval over here on the left, and we've got this interval over here on the right. Somebody describe the interval on the left using interval notation. What would it be? Negative infinity to -1. And that's a parenthesis, right? And this is a union, so we're either going to write the word or we're going to write the symbol. Somebody describe the interval on the right for me. It's from 4 to infinity. 4 gets a bracket. Infinity always gets parentheses. And these have to go in order from left to right. Okay? Negative infinity to -1. Smallest to greatest. 4 to infinity. See, the order of all my interval notation slots is ordered from smallest to largest. So there's 3 ways to write the solution of this inequality, and that's all 3 ways, right? X is less than -1 or x is greater than 4. That's the inequality view. Then we have the interval notation view, and then we have the number line view. There's 3 different ways you can represent the answers to an inequality. Okay? All right. Y'all remembering this well enough? Do we need to do any more and or examples? You guys got the ands and the ors? Okay. We could make a cheer out of that. Like the hays and the hoes, but we got the ands and the ors. No? Hey! You know the cheer?
No. Can't say I do.
Oh well, I dated myself. The roof is on fire. The roof is on fire. All right. I don't know what I'm talking about. All right. What is the solution to this inequality? X plus 5 is less than 1. Or -2x is less than or equal to -6. Are there any of these that we could eliminate just by looking at them? C? Why can we eliminate C? It's an intersection, right? C is an intersection. This graph is clearly an intersection. Or problems aren't going to stop. What about B? Can we eliminate that? Maybe. What if both of these had the same solution? Then the union would be that. But they're not it's not likely to. This one's going to have a solution of x is less than -4. This is going to have the solution of x is greater than or equal to 3. Right? That looks like it's going to be which of these answer choices? A. Answer choice A. And we may actually have some multiple choice questions on this next test. Okay. Do what? This is on the ACT. It absolutely is. It's annoying.
I don't remember. Oh, no, I do remember this one. I'm pretty sure I just guessed B.
You missed it. It's not B.
I'm on the ACT, I guess.
Oh, it's the ACT. All right.
I'll give memory.
Okay. Now here's some examples with the interval notation. What would this look like? What are these two inequalities? Y'all help me out with this. We're just going to translate these into, work backwards from interval notation into a graph and to an inequality. Yes?
We have some that we've been writing the infinity sign.
Yeah.
That we're writing double zeros.
That's the way I write infinity. I'm sorry. I'm not very, yeah, it's the same thing. I just kind of write my 2 zeros together. I'm not very good at infinities. If I do infinity like this, I'm not very good at it. It looks like a broken pair of eyeglasses. Hey, Will, Logan, y'all join us. We're discussing my lack of proclivity toward writing infinity symbols. The lack of a proclivity. That is something, right? Is it the anti-proclivity? All right. Now listen. Listen.
You always have to put parentheses on the
Infinities always get parentheses, yes. So, Johnson, what would this inequality be on the left here? If I wrote that as an inequality, what would it be? It's definitely a closed circle. And it's definitely related to 4, right? This is x is less than or equal to 4. Yes, this intersection, right? That's an and problem. Just helping you to work backwards from some things, give you a little better understanding of things. Okay? This inequality on the right would be what? X is greater than or equal to negative 2. Yeah? And this is an and problem, so if we were to graph this, what would it look like? Negative 2, 4. We're going to be less than or equal to 4. Y'all watch. Don't assume anything. Less than or equal to 4. Greater than or equal to negative 2.
Students, pardon the interruption. Just a reminder, we're going to turn the bells off in the main building only. The teachers dismissed at the proper
Fail.
time. As you're transiting between the main building and East Wing, we will ask you
We got
to
15
go around
minutes.
like you did on Tuesday.
Come on, Mr. Wrigley.
Our matinee, performance of Lion King
He might
here
watch this.
is going on.
Come on, Mr.
Thank you
Wrigley.
for your cooperation.
Interrupting my class, Mr. Wrigley. All right. Less than or equal to 4. Let's get this right. That's this way, right? Greater than or equal to negative 2. That's this way. So the intersection of these two sets is this little bitty set right here between negative 2 and 4. So y'all watch. Y'all watch. This is equal to
question.
negative 2 to 4.
How do you know which way the greater than or equal to how do you know if it's going to be greater than or less than?
Right here.
Yeah.
Because we're going from negative infinity up to 4. So it might help you if you looked at that from a graph, right? If I'm shading everything from negative infinity up to 4, that's this. That's x is less than or equal to 4.
So is it always going to be greater or less than?
No, this one's greater than or equal to.
No, the x. Is the x always going to equal less than whatever the number is? It's going from negative infinity?
Yes, or it could be less than if this was a parentheses instead of a bracket.
Okay.
All right, so there's not a lot of rules, but this just kind of gets into a little bit of a foreign language. So y'all understand that this set is equal to this set. And you kind of see that by going from the interval notation to the graph and then back from the graph to a more concise interval notation. Do what? You could probably shortcut it some. You probably could. I could. I'm not as smart as you are, but that's. Do what?
You're the teacher.
I am the teacher. And I know more math than you. Probably not smarter than you. Well, I probably am. Okay. All right. Oh boy, I'm really tired today. Silliness is abounding. I have a proclivity toward silliness when I'm tired. Okay. All right, so let's Zach, since you asked the questions on the last one, let's see if you can convert these to inequalities here. Y'all working with me? We got to hurry because I got to get to compound absolute value inequalities. This is the last one of these we'll do. This is obviously an OR problem, right? So we could graph these right together on a number line. We could do it that way. What would this left side look like? Zach, what would this left inequality be? It's everything from negative infinity up to negative 3. Do I close that circle or open that circle?
You would close it.
Because it's a bracket, we close it. That's right. And this is everything from 4 to infinity. And why did I just graph these both on top of the same number line? Because it's a union, right? So if I wanted to write this as an or inequality, this would be x is less than or equal to negative 3, or x is greater than or equal to positive 4. Fair enough? It's just testing your understanding of interval notation. Can you write these things
Do you have to write
backwards?
where it says 4 for the bracket around a 4 and a comma and then -3?
No. The union. This can't be. This would be that again. In interval notation, we can't shortcut this one. This one up here ended up being from -2 to 4, and so we can rewrite the interval. It's an intersection. You can rewrite the interval. Usually, if there is an intersection, it could be empty. It could be no intersection. In which case, the solution would be the empty set or no solutions. All right, let's move forward. I want to get to absolute value inequalities. Okay?
Yuck.
It's really not yuck, because we're going to think of this as the distance from 0, right? So what I want to do is kind of, let's talk about what the distance of x is greater than 5. Let's just deal with x. We'll get to this in just a second. Because what did I tell you this stuff in the inside represents? It's just a blob, right? I want you to think about the concept, and then we'll apply it to the blob. Whatever the blob is, we'll apply it to it. The absolute value of x is greater than 5. Somebody give me a number that fits that description.
3.
3 doesn't work.
No word.
4 doesn't work. Come on, Will, think a bit. Distance is greater than 5.
8.
8 works. What else works?
Oh, I thought you were asking.
Or wait.
What else works? 7 works.
104.
104 works. So definitely, guys, listen. Definitely any x value greater than 5 works. Is that the only thing that would work? Wouldn't -8 also work? Does -8 have a distance from 0 that's greater than 5? Yes. What about -104? Yes. So we're also talking about any value that's less than -5. Okay? Now, is that an and problem, or, well, I wrote the or problem. I wrote the or. I kind of gave it away. If I had graphed it first, fail, teacher, fail. All right. Greater than 5 would be all of these things. Less than -5 would be all of these things. That's an or problem, isn't it? So if our distance is greater than a number, we're talking about going away from those values, away from 0, because our distance is greater than something. We're going away from 0. And that is typical of an or problem, right? Absolute value greater thans will always be or problems, okay? There's an acrostic that a lot of teachers use. Go to LA, of all, coincidences. This is LA versus New York day. But greater than is or, less than is and, okay? Greater is or, greater. Yeah. Less than and, okay? Greater is or. So if it's an absolute value problem. So this is going to be x plus 2 is, oh no.
What does it stand for again?
Greater is or, less than is and. X plus 2 is greater than 5, or x plus 2, our blob, is less than -5. This concept always gets a few people, even though this is the third time most of you have seen it. So what would that look like? The solution would be x is greater than 3, or x is less than -7. This is an or problem. So how do we graph or problems? One number line, slap them both on the same number line and graph them, right? Greater than 3, is this. Less than negative 7 is this. Right? What would the interval notation look like? Somebody describe this interval on the left. Negative infinity, is that better? I joined the two zeros there. To negative 7. Or 3 to infinity. So there's the three different ways that these answers can be asked for, shown, given to you, right? Inequalities, interval notation, graph.
You can ask for all three of these on the test.
You will have to be able to do all three on the test at some point. I'll ask for different forms of the answer. I'll ask you to interpret some interval notations, right? Graph and interval notation. All right? What about this one? In this particular problem, what are we looking at? We need our distance from 0 to be less than 6. What would that look like on a graph? If we just thought about it, if the distance from 0 is less than 6, that means we could go to 6, but we got to stop, right? How far could we go this way? Negative 6, so we have to stop there. So this is the solution that we're looking at for our blob. Our blob has a distance from 0 that is less than 6. So it's between 6 and negative 6. Does everybody agree with that? That's the distance from 0 that's less than 6. Does this look like an and problem or an or problem? It definitely looks like an and problem, right? It's an intersection. It's a set that starts and stops. Okay, now that means we're going to split this into x minus 2 is less than 6. That covers this piece of it. And we've got to cover this other piece of it, which would be x minus 2 is greater than negative 6. So if we were to stop and describe this process here, we write it once the way it is, and then we flip the symbol and change the sign. We write it once the way it is, x minus 2 is less than 6, and then we flip the symbol and change the sign. And then if it's greater than, it's or. If it's less than, it's and. All right, if we solve this, we get x is less than 8. If we solve this, we get x is greater than negative 4. Okay? And that gives us, we're hurrying here, negative 4 and 8. Greater than negative 4 is this, less than 8 is this. That's everything in between negative 4 and 8, right? What's the interval notation for that? Everything from negative 4 to 8. Parentheses on both sides.
Would you take points off? Would you just put the circles and only put the line in between the two circles?
You mean if you didn't show this? Yeah, I don't care if you show this up here. This is not the answer. This is the answer. Okay? Well, you need to be careful because intersections aren't always going to be just between the two numbers. You may not have an intersection. Or both of those number lines could go in the same direction. All right, let me show you what I'm talking about. If we were looking at the scenario where we were given an and problem that went this way, where's the intersection? It's over here, right? So you got to be careful. You need to use those graphs, but that's not part of the answer. This stuff up top is not part of the answer. Only what makes it onto the number line is the answer.
Would you count off if we just put the one line?
Not if the graph is correct, but if the graph is incorrect, I would. All right. So what would this be? And or? Y'all, let's go through these real quickly. And or? Or because it's greater, right? So it'd be 2x minus 4 is greater than or equal to 8, or 2x minus 4 is less than or equal to negative 8, right? All right? So this would be an or problem, and you graph or problems like that and write the interval notation like that. I'm going through this a little quickly. If you wanted to watch this later, you could pause and kind of have a look at this. What about this example 9? We got to see this. We got to see this. Now, we got to be aware, right? If you have negative signs related to distance, when is a distance greater than -8? Always. Why? Because this is a positive value. And a positive value is always greater than -8, so that is all real numbers. What about this one? Can our distance from 0 be less than -2? No, distance is always positive or 0, and that can't be less than -2, and so this has no solutions. Now, the good news here is that if you write these as and problems or problems and you solve them, your graphs will still show you that this has no intersection. Okay? The graphs will show you this. If you're graphing above the line, they won't cross over each other. And this one, you'll end up shading the whole number line, because they'll go in opposite directions and cross right over each other. You'll shade right through each other. And you don't have to catch these like you do with the equations. You can follow the process and go from there. All right? I think that's enough. I want to show you one more thing. Real quickly. Is this right here and or? Neither. Why? Doesn't have absolute value, so don't get tricked by that. You guys have a great day. It will be.